morning students, welcome to Maths online class. Next you have Euclid's 5 postulates that are postulate 1, a straight line can be drawn from any one point to any other point. Suppose you have 2 points like this, then you can draw a straight line from one point A to another point B. Okay, so that is a postulate 1. A straight line can be drawn from any one point to any other point like this. Okay, so that is the first one. Next second postulate, postulate 2, a terminated line can be produced indefinitely. Terminated line means Euclid used the word terminated line for this. Nowadays we are saying terminated line as a line segment. Okay, so line segment, for that Euclid used the terminated line, means a line segment can be produced indefinitely. Line segment means that is the part of the line. Suppose this is a line AB, line segment AB, then you can produce this indefinitely, means you can extend this line to any extent in both direction like this. Okay, so that is a postulate 2, that is a terminated line, means a line segment can be produced indefinitely, means you can extend a line segment indefinitely in both the directions. Okay, you can produce AB in this direction, or you can produce AB in left side also. Okay, to any extent you can produce a line segment. That is a second postulate. Next third one, a circle can be drawn with any center and any radius. Suppose you have one point say A, and if you have like this line, then you can draw a circle with the A as a center and this line segment as a radius like this. Okay, so what is a postulate 3? You can draw a circle with any center and any radius. You can take any radius. You can take a radius of this much unit, or you can take a radius of this much unit. You can draw a circle with the center A and radius this much. Okay, so you can draw a circle. You can draw a circle with the any center and any radius. And next postulate is fourth one, all right angles are equal to one another. All right angles are equal to one another means suppose you take a right angle, small right angle like this, or a medium right angle like this, or a bigger right angle like this. All these right angles are equal to one another, whether they are small, big or medium. All these right angles measure same, that is 90 degree. All these right angles measure how much? 90 degree. So all right angles are equal to one another. That is postulate 4. And next fifth postulate, that is a little bit complicated compared to other 4 postulate. Fifth postulate is a little bit complicated, but the summary of that is very easy. Okay, postulate 5, that is, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than 2 right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles. Okay, this is a bigger one also compared to other 4 postulates. So what it says, postulate 5. See, suppose two straight lines are like this, AB and CD, and I will take one more straight line, PQ. How PQ is the line of PQ if a straight line falling on two straight lines. Here a straight line PQ, that is falling on two straight lines AB and CD. Okay, so here in a fifth postulate, if a straight line, I taken that as a PQ, if a straight line PQ falling on two straight lines, which two straight lines we taken, AB and CD. Okay, just to explain this postulate, not for what for notes, just to explain rough figure, this one is So here you have a straight line PQ that is falling on two straight lines AB and CD, and that makes that means this PQ makes interior angles on the same side of it taken together less than two right angles. Two right angles means one right angle means 90 degree. Two right angles means 90 plus 90. Taken together means 90 90 how much 180 degree. Okay. Taken together less than two right angles. You can see on which side you have interior angles taken together less than 90 degree, less than two right angles. Two right angles means less than 180 degree. Okay. See here this interior angle and this interior angles. These are the two interior angles on the left side of this straight line PQ. You can see that this interior angle is less than 90 degree. Okay. Clearly you can see if interior angle is 90 degree, then these two lines are exactly perpendicular to each other. But here you can see they are not perpendicular to each other. You can see in the figure that they are less than 90 degree, these two both interior angles, right? For example, if I take this as a 70 degree and this as a 80 degree, then this is less than 90 degree, this is also less than 90 degree, and if you take that together, what it gives 70 plus 80, that gives you 150 degree, right? And 150 degree, that is less than 180 degree. Okay, 150 degree, that is less than 180 degree. So on the same side of it, two interior angles on the same side of it taken together, we taken these two interior angles taken together, and that gives you 150 degree, and that is less than two right angles, means less than 180 degree. Then the two straight lines means AB and CD, if you produce that indefinitely means to any extent you can now produce that indefinitely will meet on that side on which the sum of angles is less than two right angles. Okay. See, I will produce these two lines AB and CD indefinitely. Okay, you can produce indefinitely means to any extent you can produce. I will produce AB and CD in this direction, A and C point direction. Okay, so then you can see that these two straight lines, if you produce that, that will meet means intersect at a point on that side on which the sum of two interior angles is less than two right angles, means less than 180 degree. I hope you understood. If you see another side of this straight line PQ, what is this interior angle 70, this side interior angle is 70, total angle on one side of a straight line should be 180 degree, that you know. So how much left? Here 110 degree and here 80 degree is there, so how much is remaining? 100 degree, and both are both are more than right angles, right? More than 90, 110 and 100 degree, both are more than 90 degree. So here are sum of these two interior angles is how much? 210, that is not less than 180 degree. So and if I produce these two lines in this direction, that will never meet each other. If you produce AB and CD in this direction, B and D direction, then they will never meet each other, they will go far away. Okay, so what it says, postulate 5, the summary part of that postulate 5 is only this much. If transversal intersects the two straight lines, then the two straight lines if produced will meet on that side on which the sum of two interior angles is less than 180 degree. I hope you understood. If not understood, I will explain you once again. Okay. See, if you take two transversal lines AB and CD, and for example here I will take see, first I will draw two parallel lines AB and CD, and if you draw a transversal PQ, then here both I taken as a 90 degree, both interior angles you can see 90 degree, here 90 degree and here 90 degree, okay. And here this line PQ is falling on these two straight lines AB and CD, and if you take this side, then if you take two interior angles on the left side of a transversal PQ, then the sum of that is equal to 180 degree, and here also equal to 180 degree. So what happens here, if you produce AB and CD lines in any direction, they will never meet each other, okay. They will never meet each other. They are, why? Because they are parallel lines. If you draw two straight lines like this, two straight lines AB and CD like this, then clearly you can see that here this interior angle and this interior angle is less than 90 degree, and this interior angle is also less than 90 degree. For example, if I take this as a 50 degree and this as a 60 degree, then if you take these two interior angles together, what it gives together means if you take a sum of that, that gives you 60 plus 50, 110 degree, right, and that 110 degree, that is less than 180 degree, okay. So if a sum of two interior angles on the same side is less than 180 degree, then the two straight lines will meet on this side. If you produce two straight lines AB and CD, that will meet on that side on which the sum of two interior angles is less than 180 degree, okay. Here if you extend like this, that will meet, you can see meeting point somewhere here, okay. But if you extend AB and CD in another direction, that is if a sum of two interior angles is more than 180 degree, on that side straight lines will never meet each other, okay. They will go far away, okay. So straight lines will meet on which side? On that side on which the sum of two interior angles is less than 180 degree. That is the summary of this fifth postulate. I will say once again the summary of fifth postulate, that if a transversal intersects two straight lines, then the two straight lines AB and CD, if produced, that will meet on that side on which the sum of two interior angles is less than 180 degree. On which side sum of two interior angles is less than 180 degree, that side two straight lines will intersect or meet each other if you produce that two straight lines. That is the summary of fifth postulate, okay. Thank you. After Euclid stated his axioms and theorems, he used that axioms and postulates to prove some results, and these results he used to prove some more results by deductive reasoning. The statements that were proved are called propositions or theorems, and Euclid he proved, deduced total 465 propositions in a logical chain by using his axioms, postulates, definitions and theorems that were proved in a long chain. And we already used that many times in a geometrical part, okay. Thank you. Next, which of the following statements are true and which are false? Give reasons for your answer. First one is only one line can pass through a single point, okay. Only one line can pass through a single point. Before deciding whether this statement is true or false, let me say something. Suppose you have one point like this O, then how many lines you can draw through this point? See, one line you can draw like this, another line you can draw like this, another line can draw like this, one more line, next line, and like this, like this, like this. Infinitely many lines you can draw through a single point. So now you decide this statement is true or false. Only one line can pass through a single point. Is it true or false? This statement is false, because this figure itself indicates that you can draw infinitely many straight lines through a single point. Okay, so this statement is what? False statement. False statement. False statement, because why? Because I showed you through a single point you can draw infinitely many straight lines. Okay, because we can draw infinitely many straight lines through a single point. And next, second statement is that there are infinite number of lines which pass through two distinct points. Suppose you have two distinct points, say A and B, then how many lines you can draw through both points A and B? See, I can draw only one line through these 2 points, right? See, you have 2 points A and B. You can draw only one line passing through both points A and B. So, what you can say about these statements? So, there are infinite number of lines which pass through 2 distinct points. But we can draw only one line passing through 2 distinct points, right? So, this statement is also false statement. Okay. So, second one is also false statement. This is answer. False, because we can draw only one line. Okay, only one line through 2 distinct points. 2 distinct points. Okay. Still you have 3 more statements. I will give one by one. Okay, thank you. Next statement is a terminated line can be produced indefinitely on both the sides. Terminated line means a line segment. You know that line segment we can produce in both directions. Suppose this is a line segment AB, then you can now you can extend that line segment in both directions to any extent. Okay, so that is a terminated line can be produced indefinitely on both the sides. That is nothing but a postulate 2. That is obvious universal truth that you know. So this statement is what? This statement is true by what? Euclid's second postulate. Okay, true statement, true by postulate 2. Okay, and next statement, if 2 circles are equal, then their radii are equal. If 2 circles are equal, then their radii are equal. See, suppose you have 2 circles with the same radii like this. If 2 circles are with the same radii, for example 2 centimeter or 2 centimeter, and if you keep this circle on this circle, this is a rough figure, not exact figure. Okay, if you keep one circle on another circle, if you keep one circle on another circle, then they will coincide each other. Okay, and we have one Euclid axiom that things which coincide each other are equal to one another. So what happens if radii of two circles are equal, then they will coincide each other, right? If they coincide each other, then according to Euclid's axiom, what we can say about these two circles, they are equal. So two circles are equal if and only if their radii are equal. So you can say that if radii of two circles are equal, then that two circles coincide each other. And we have axiom that things which coincide each other are equal to one another. Now these two circles coincide each other. Why? Because they have same radii. So we can say these two circles are equal. Okay. So that is by using Euclid's axiom. I forgot which number I gave for that axiom, using that axiom. Okay. So here this statement is true because if radii of two circles are equal, then they coincide each other, and hence they are equal. They are means the circles are equal, hence they are equal by Euclid's axiom. Euclid's axiom, which axiom? Things which coincide each other are equal to one another. Okay. We have this axiom, Euclid's axiom, that is things which coincide each other are equal to one another. So what happens if radii of two circles are equal? They will coincide each other. So they are equal to one another, means two circles are equal to one another. That I give as a reason. Okay. Because if radii of two circles are equal, then they coincide each other and hence they are equal by Euclid's axiom. And Euclid's axiom I gave in a bracket. Which axiom we used? That axiom I gave in a bracket. That is, things which coincide each other are equal to one another. Okay. And next statement is, in the figure, if AB is equal to PQ and PQ is equal to XY, then AB is equal to XY. AB is equal to XY. You are given three line segments AB, PQ and XY. They are like this. AB is equal to PQ and this PQ is equal to XY. So then now AB is equal to XY. Like this we used many times. Okay. And how this statement is true or false? This statement is true. Why? Because see here, AB, the line AB, that is equal to PQ, and you see this in a reverse way, XY, that line XY is equal to what? That is also equal to PQ. And you have one axiom that things which are equal to the same thing are equal to one another. Things which are equal to the same thing are equal to one another. Like that you have one axiom. So now AB and XY, these two line segments are equal to the same line segment PQ. So these two line segments are equal to one another. That is by using what? Axiom. Which axiom? Things which are equal to the same thing are equal to one another. Using that axiom, we can say AB is equal to XY. Okay. Actually we used like this many times. So that is actually by using Euclid's axiom. So this statement that is true. Answer true, because by using Euclid's axiom, that things which are equal to the same thing are equal to one another. Continuation I'll write above. Okay. In the given figure, what we have? In the given figure, AB is equal to PQ and XY, that is also equal to PQ. These two line segments AB and XY are equal to the same thing. Okay, therefore AB is equal to XY, we can say. Okay, therefore AB is equal to XY. Okay, thank you. Next one is if a point C lies between two points A and B such that AC is equal to BC, then prove that AC is equal to half of AB and explain by drawing the figure. I already drawn the figure. This figure is not given to you in the question, you have to draw. Okay, this figure I already drawn. I drawn one line segment AB and middle of that I taken one point and I taken that as a C. Now AC is equal to what? AC is equal to BC. Okay, AC is equal to BC means that is understood that C is the midpoint of the line segment AB. Now you can see A and B are 2 points and C is a point in between that A and B such that AC is equal to BC. Now using this figure you prove that AC is equal to half of AB. Okay. So AC and BC are equal, that thing you have to keep in mind. I will start with the AB. Now AB is equal to, in AB you have two line segments, right, AC and CB. So AB is the sum of two line segments AC and CB. So AC plus CB, this much plus this much. Okay, AC plus CB. But what is CB? CB you can write as a BC also. What is a CB? That is a AC, right? Since we are given BC is equal to AC, that is given. Since we are given BC is equal to AC, I here wrote BC as a CB. Okay, BC and CB, they are one and the same. So I replaced this CB by AC. Now AC plus AC is what? 2 times you have AC. 2 times AC is added, means 2 AC. 2 AC is equal to what? What you have on left side? Left side you have AB. Okay, AB is equal to 2 AC. From this we can get this one easily. Just to take that into to another side. So then what you will get? AC is equal to, if you take into to another side, that will be by 2 another side. So half into AB. What we done here? We taken this into 2 this side as by 2. Okay, writing AB by 2 is the same as half into AB, or otherwise you can write like this, AB by 2, and you can write AB by 2 as like this also, half into AB, it is equal to AC. If you simplify this, 1 into AB, you will get AB and dividing by 2. Okay, so AB is equal to, AC is equal to half of AB. That you can see by this example also. Suppose I take AB 10 centimeter and if C is a point in between these 2 points, then what is AC length? AC length is 5 and CB length is also 5. Clearly you can see that AC, that is 5 centimeter, that is half of AB. Half of AB. AB is 10. Half of AB is what? Half of 10 is 5. Okay. So that you have to prove here in general. Okay, thank you.